In general, the volume of a solid is the integral of the area of a slice multiplied by dx or y, the height. When dealing with solids of revolution, our slices were always discs or washers. But in these new examples, the cross sections can be different shapes. So, in example 4, the base of the region is enclosed by the circle x squared plus y squared equals 1. So I could do a quick sketch of that. We have a circular base. Of radius 1. So they want us to have cross sections perpendicular to the x-axis that are squares. So that means there's going to be a cross section here perpendicular to the x-axis who is sticking out and is a square. So I already told you it wasn't going to be pretty. And imagine that that square is sticking out up into the air. So what is the volume of that cross section? Well, first, that cross section is dx thick, and we know it's a square, so all 4 sides are equal. So we know it's going to be the area of a square. Area equals side squared. What is the length of this side? Well, we know that this thickness or the width of this cross section is dx since it's perpendicular to the x-axis. So I know my functions need to be in terms of x. Let's see, the top half of this function is y equals positive square root 1 minus x squared, and the bottom is y equals negative square root 1 minus x squared. So if I'm trying to figure out the length of this side, it is square root 1 minus x squared subtracting negative square root 1 minus x squared, which is 2 square root 1 minus x squared. So if I know the length of this side of my square is 2 square root 1 minus x squared, then the volume is the integral of that side squared, because that's the area of the square, multiplied by its height. Now, what x values is that going from? From -1 to +1. Oops, and I forgot to square it, right? Because it's a square, so I take my side and I square it. So that becomes the volume is the integral from -1 to 1 of 4 times 1 minus x squared dx. So I'm going to go ahead and pull that 4 out in front of my integral. Ugh, that doesn't look great. Let me pull that 4 out in front of my integral. So what's the antiderivative of 1? It's x minus x cubed over 3 from -1 to 1. So our volume is 1 minus 1/3 minus -1 plus 1/3 units cubed.